Hello everyone, my name is Huijing Zou and I'm currently a graduate student from New York University. My research topic is using NMR to analyze the sodium ions distribution within the hydrogel desalination system. The mechanism of hydrogel desalination is based on the electrostatic imbalance between the fixed charge groups in the polyelectrolyte hydrogels and the surrounding solution. In this project, we are analyzing the desalination of sodium polyacrylate hydrogels, or I will call it PSA. We add the PSA hydrogels into salt solution, then wait until the hydrogel is fully swollen with water. The chloride ions will be repelled back due to the electron repulsion with carboxylate groups. Partial amounts of sodium ions remain in the hydrogels, while other free sodium ions tend to be balanced with chloride ions outside of the hydrogel. Then we remove the supernatant and apply pressure on the gel to extract desalinated water. You may have heard of MRI, which can generate detailed images of the patient's body. Now you can consider the patient is the sample tube. We can use NMR imaging to visualize the spatial distribution of sodium ions inside hydrogels. The difference between standard NMR measurement is that the NMR imaging has applied additional gradient pauses during the detection. We prepare the samples with different amount of hydrogels to ensure hydrogels and supernatant show in the detection region simultaneously. Here we can use NMR imaging to track the sodium ions distribution during the desalination process and also measure the integral changes as increase of temperatures. Sodium has a span number of 3/2, which provides an asymmetric electron distribution. The relaxation rates can largely be affected by the surrounding electric field gradient. We can determine bound sodium ions and free sodium ions based on the relaxation rates. Because the hydrogel phase actually is many gel clusters accumulate at the bottom of the tube, which contains both hydrogels and salt solutions. In order to get more accurate data only for bound sodium ions, multiple quantum filtered NMR is also applied in our analysis. It helps us to confirm the presence of bound sodium ions, including the sodium ions bound with the binding site of the fixed charge groups and the sodium ions loosely interacting with the hydrogel phase. This method can also be combined with NMR imaging. The final slide is a short summary of my current results. For the future plan, I will also apply this analysis on the thermoresponsive polyelectrolyte hydrogels. Our final goal is to use NMR to develop an efficient way to determine hydrogel desalination performance and hopefully use this method to provide supportive information for future research on thermoresponsive polyelectrolyte hydrogels. And if you have any question about my project, please always feel free to email me. Thank you.